Hi everybody, today we're going to be talking about writing linear equations in standard form. This is going to be part one. There's actually going to be three different parts, so this is part one. First of all, standard form is ax plus by equals c, where a, b, and c are real numbers. So a, b, and c just stand for numbers here. There's not any particular intercept or slope, they're just numbers. And a and b are not both 0. One or the other could be 0, but both of them cannot be 0 in order for it to be a linear equation. So first of all, write the following equation in standard form and slope-intercept form. I generally think it's easier to do slope-intercept form first and then change that into standard form. So slope-intercept form, I know I need y by itself, but in order to be able to combine like terms, the first thing I need to do is distribute. So I'm going to distribute my 2, and I'm going to get y minus 2 equals 2x plus 14. Now I can add 2 to both sides, so that y is by itself, and I'm going to get y equals 2x plus 16. So that is my slope-intercept form. And now we're going to take that and make it standard form. If you notice, in standard form, all of the x's and y's are on the same side. So in order to get my x's over to the other side, I'm going to subtract 2x from both sides. That's going to get rid of them on the right and just leave me with 16. And over on the left, I'm going to have negative 2x plus y equals 16. That is my standard form. I know we did y minus 2x, and this technically is y minus 2x, but in standard form, we like to have our x term first. So that's why I wrote my negative 2x plus y equals 16. Let's try another one. All right, so again, we're going to do standard form and slope-intercept form. So again, I'm going to distribute. Notice here I just have a negative. I do need to distribute that negative to both terms. That's a very easy mistake to make, to forget to do that. Don't forget to distribute it to both terms. So this is going to be y plus 6 equals negative x plus 4. That negative is going to cancel out that minus in front of the 4 and make it plus 4. Now I'm going to subtract 6 from both sides, and I'm going to get y equals negative x minus 2. So that's my slope-intercept form. Now I want all of the x's and y's to be on the same side for standard form, so I'm just going to add x to both sides here. That's a nice easy one. So here I'm going to have x plus y. Again, we want x term first. X plus y equals negative 2. And that's our standard form. Right, for this one, I would like for you to pause and try it on your own, and then hit play when you're ready to check to see if you did it right. All right, hopefully you just did that on your own, so let's check and make sure that you did it right. First, we're going to distribute the 5, and I'm going to have y minus 8 equals 5x minus 30. Add 8 to both sides to get y by itself. So I'm going to get y equals 5x minus 22. Notice this is minus 30 and plus 8. That's going to give me negative 22. So be very careful there. So that's my slope-intercept form. Now let's make this into standard form. I'm going to subtract 5x from both sides. And I'm going to get negative 5x plus y equals negative 22. And that is my standard form. Let's try one more. Again, pause it and hit play when you're ready to resume and check your work. Okay, let's check and see how you did. We're going to distribute negative 5, so we're going to get y plus 12 equals negative 5x minus 15, or plus negative 15 if you prefer. Subtract 12 from both sides. So we're going to get y equals negative 5x minus 27. We have negative 15 and negative 12. If you put those together, you get negative 27. Watch your integer rules there. That's my slope-intercept form. Let's make that standard form. Add 5x to both sides. And we're going to have 5x plus y equals negative 27. And that is my standard form. All right. Here we have a new set of directions. It says write two equations in standard form that are equivalent to the given equation. Obviously both of these are the same, but since I'm going to find two equivalent equations, I just wanted you to be able to see them next to each other. So the first thing I notice about this equation, 5x plus 10y equals 15, all three of the terms that I have there have a factor of 5. So one thing that I can do, I can divide both sides by 5. And that's going to give me x plus 2y equals 3. 5 divided by 5 is just 1, and 1x is just x. That's where that came from. So this is one example of an equivalent equation. It is not the only one. There are infinitely many. That was just something that jumped out at me. Something else you can do, if you can multiply both sides of the equation by a certain number. As long as you do the same thing to both sides, they will be equivalent. So let's pick an easy one. Let's just do 2. I'm going to multiply both sides by 2. And since I'm multiplying the entire side by 2, I am going to need to distribute here again. So I've got 10x plus 20y equals 30. So that is another equivalent equation. Again, those are just two examples of things you could do. There are tons of different ways that you can do this. Those are just two easy ones that jumped out at me. A way that we can check to see if we're right, we can pick an ordered pair that makes the first equation true and make sure it makes the other ones true as well. A really easy one to pick here is 1, 1. If we plug 1 in for x and 1 in for y, we'll see what we get. So if we plug 1, 1 into our original equation, we're going to get 5 plus 10 equals 15. That's an obviously true statement. If we plug 1 and 1 into our x plus 2y equals 3, we're going to get 1 plus 2 equals 3. That's definitely a true statement. Hopefully you all know that by now. And if we plug 1 and 1 into our 10x plus 20y equals 30, we're going to get 10 plus 20 equals 30. So all of those are true statements and using the same ordered pair. So all of those are equivalent equations. All right, let's try another one. All right, so here I have negative 3x plus 3y equals 1. I could divide both sides by something, but that's going to give me a fraction, and I really don't want to deal with fractions if I don't absolutely have to. So on this slide, I'm going to pick two different numbers to multiply by. Something that is one of my personal pet peeves is having a negative leading coefficient. I don't really like that. Again, if I can help it. Sometimes you can't help it, but here I can. I can multiply both sides by -1. Oops. There we go. If I multiply both sides by -1, then I'm going to have positive 3x minus 3y, or plus negative 3y, equals -1. This is an equivalent equation. And now I've got a positive leading coefficient. I like that much better. Let's just pick another number to multiply. It doesn't really matter which number we pick. We can pick any number that we want. We've already done 2, so let's do 3. Let's multiply both sides by 3. All right, so we're going to get negative 9x plus 9y equals 3. That's another equivalent equation. Again, you could multiply or divide these by anything and get an equivalent equation. The key is you need to do it to both sides of the equation, and you need to do it to the entire side, which means you're going to need to distribute. So again, let's pick something that will make this true. Actually, I think 1 and 1 will work here again. If we plug 1 and 1 into our original equation, we're going to get negative 3 plus 3 equals 1. No, actually that doesn't work. Let's do... Oh goodness. All right, actually I think we're going to have to do a fraction here in order for this to work. So I am just going to show my work down here because that's a little hard for me to do in my head. So let's do 1 and 4/3. Let's use that as our ordered pair and let's plug it in. So if I plug 1 in to my original equation, I'm going to get negative 3 plus 3 times 4/3. Okay, if I multiply that out, the 3's are going to cancel, so this is just going to be negative 3 plus 4. And that certainly is equal to 1, so that checks out. Now if we plug 1 4/3 into our 3x minus 3y equals -1, we're going to get 3 minus 3 times 4/3. Again, the 3's are going to cancel, so now we're going to have 3 minus 4 equals -1. That is certainly true as well. One more to check. if we plug 1 4/3 in here, we're going to get negative 9 plus 9 times 4/3. Sorry, just giving us a little more space. The 9 and the 3, we're going to cross cancel, and we're going to get 3 times 4. So this is actually going to be negative 9 plus 12. And that is negative 3, which, as you can see, or positive 3, excuse me, which, as you can see, was what we came up with. So all of these are indeed equivalent equations. That's an easy way to check. Thank you very much for listening. Stay tuned for part 2.